And finally, in part 3, we're going to talk about verifying the inverse. So I understand that you can take a function and find its inverse. You can then take that inverse and find the function that's its inverse, going back to the original. But there's a much easier way and a different way to verify that you found an inverse, and that's using compositions. So if a function is one-to-one and f inverse exists and satisfies this condition. So to verify, what we're going to do is we're going to come in and take f, we're going to compose it with the inverse. And if we do that, I get just x. And this also has to happen. So this is not a one thing, this is a both things. If you take the inverse function and compose it with the original function, you will also get just x. And you did a couple of these in the previous section, setting us up for this. So this is the only method. This is the only method you can use in our class to verify the inverse function. So example 5 says, use the algebraic method to find the inverse and then verify the inverse you found is correct. So we're going to do f of x is equal to 2/3 x minus 5. So let's go find the inverse. So this is y equals 2/3 x minus 5. It's a linear function, so its domain and range is all real numbers, just as a comment. Now we're going to interchange. So x is equal to 2/3 y minus 5. Now we're going to go solve for y. So we'll move the 5. And then what I'm going to do is I'm going to multiply by 3/2. So our inverse function is equal to 3/2 times x plus 5. And there's the inverse function. Notice it's also a line. You could distribute the 3/2 in if you want. I'm choosing to not, but there's the inverse function. Okay, now what we want to do is verify them. So to verify them, what we're going to do is find f compose f inverse. And this is really why we did section 6.1 with the inverse function, so that we could do this verification in this section. So that means I'm going to pick up the inverse function, that's this guy, and plug it in place of that x. So in place of that x, we're going to plug this. So again, to write it out, what we're really finding is f of 3/2 of x plus 5. So that would be 2/3. And now in place of the x, we're going to plug 3/2 times x plus 5. And now I'll have a minus 5. So all I'm doing is replacing that x with the other function. Well, notice the 2/3 and the 3/2 cancel. So they're gone. And that gives me x plus 5 minus 5, which is equal to x, which is what they said it would do. So check, it works. Now I got to go the other way. So now we're going to do f inverse compose f. So that would be f inverse of the original function, which was 2/3 x minus 5. So now we're going to replace the x in this inverse with the other function. So that would give me 3/2, and then I have a parenthesis, and then in place of this x, I'm going to write the 2/3 x minus 5 plus 5. So this time the 5s are going to cancel first. And I end up with 3/2 times 2/3 x, and then the 2/3 are going to cancel with the 3/2, and we're left with x. So it also works. Cool. Now notice that what we did is they're undoing each other in the opposite direction. So on this one, we canceled the fractions first, and then we canceled the 5s. Down here, we canceled the 5s, and then we canceled the fractions. So yeah, that's because, again, if you're getting dressed, let's talk about shoes and socks, right? In the morning when you put them on, you put your sock on, you put your shoes on. To get undressed, to undo that, you take your shoe off, then your sock. You can't take your sock over your shoe, folks. It doesn't work. Okay. So the only way to verify the functions are inverses is to compose them. Okay. Okay, and then finally, the last example, we've already alluded to this or talked about it. It simply goes on to tell us the graph of a function and its inverse. Graphing a function and its inverse function on the same axes reveals the graphs are reflections across the line y equal to x. So for example 6, it says for each graph shown below, draw a graph of the inverse function. So we have the original function has a point down here at -2, 0, and another point over here at 2, 0. And it looks like this. So there's the original function. So to graph the inverse function, let me go ahead and graph that in red, different colors so you can see it. All we're going to do is take the 2 points they gave me and interchange their x and y values. So the point that's at -2, 0 would be over here at, sorry, I need to be really, really careful. I'm not having a good morning. Make sure you write them correctly, because when you go to interchange them, you're going to need that. So this is 0, -2, and that one is 2, 0. So now when I interchange the x and the y values, I'm going to get -2, 0, which is right here. Interchanging this one will give me 0, 2, which is right here. These have the same kind of curvature. So there it is at inverse function. Beautiful. Now again, notice that they are crossing. They don't have to cross. If they do cross, they'll actually cross right on top of the line y equal to x, which should make sense because the x and y value are the same there. So that's why they comes out to be there. But sure enough, these guys reflect over the line y equal to x. They're symmetrical about that line. Kind of cool. Okay, it's another way to visually verify that they're inverse functions. The second example on that one's a little bit more complicated, and we need some specific points so that we can do this interchanging of x and y. So I have a point over here at -5, -2. So that point is at -5, -2 on the original function. I'm not going to label it on top of the graph because it just gets too messy in there. So we have a point at -5, -2. We also goes through the origin, so we'll include the origin. I need another point out here somewhere. It looks like it's at -7, -5. No, -7, -6. So there's another point out here at -7, -6. So this is doing this. It goes to the origin. On the other side of the origin, it has a point at 2, 4. Looks like that. So 0, 0, 2, 4. And then just to get that dry, it looks like 6, 5. 6, 5. Okay, whew, there's the function. Okay, so to graph the inverse, all we need to do is take every set of x and y on a point and switch their x's and their y's. So for our inverse function, our first point is going to be at -2, -5. We'll have another point at -6, -7. The origin is fine. 4, 2. And then finally 5, 6. Okay, so -2, -5 is going to be down here. 5, -2, -5 is right there. I have -6, -7. So -6, -7 is going to be down here. That's the straight part of this. So it's doing this. It goes to the origin, and I also need the point 4, 2. And then 5, 6. So 5. And there's the inverse function. Sure enough, you're going to fold across this line y equal to x. It's kind of a cool picture when you're all done with it. But there's a function and the graph of its inverse function. We could go ahead and find the domain and range on this one. Not very exciting because it's all real numbers for everything. But back over here, you can see that the domain and the range are going to interchange themselves. So, and that wraps up section 6.2. And then we'll move into section 6.3 next, which talks about a very specific type of one-to-one function called the exponential function.